Okay, take a quick look around you right now. The screen you're staring at, the air you're breathing, maybe the coffee cup sitting on your desk, it's all matter. Everything. But how do we actually organize and make sense of this endless variety of stuff that makes up our reality? Well, we classify it. So today, we're essentially decoding the universe by looking at matter's most fundamental characteristics. We're talking physical versus chemical properties. Okay, let's dive right into this. The source material actually kicks things off with a pretty profound piece of ancient wisdom from Matthew 7:16. By their fruit you will recognize them. Now, you might be wondering, what does ancient scripture have to do with modern chemistry? And the answer is honestly absolutely everything. Think about a tree for a second. You don't need to chop it down and, analyze its DNA in a lab to figure out it's an apple tree. You just look at the apples. The fruit tells you the identity of the tree. And in that exact same way, we identify matter by its unique, observable traits, its fruit, so to speak. Every single substance in the universe has a specific set of characteristics that just announce to the world exactly what it is and what it's capable of doing. Moving on to Section 1, identifying the world around us. Let's break down exactly how we classify all this stuff. To become true material detectives, we have to divide these observable traits into two major categories. Let's start with the first one, the physical property. So a physical property is basically a trait that can be observed or measured without changing the substance's chemical identity. What does that actually mean in plain English? It means you're just looking at what's already there. You aren't fundamentally altering what the thing actually is. Like if you pick up a rock to feel how heavy it is, or if you look at a piece of gold to see that shiny yellow color, you're observing physical properties. You can measure its hardness, you can check its density, but at the end of the day, that rock is still a rock, and that gold is absolutely still gold. You haven't destroyed its core identity just to learn about it. But then we have the chemical property. And this is where the real drama of science happens. A chemical property describes a substance's ability to undergo a specific chemical change and transform into an entirely new substance. And I really want to emphasize that word new here. That is absolutely crucial. A chemical property is all about potential. It's about transformation. It's not just about what a substance is right now in this exact moment. It's about what it literally has the power to become under the right conditions. So to observe a chemical property in action, the original substance has to fundamentally change its identity. It has to become something else completely. You can really see the visual contrast here. On the left side, we've got things like color, density, melting point, boiling point, hardness. These are all your physical properties. I mean, if I melt a block of ice, sure, I'm observing its melting point, but I'm really just turning solid water into liquid water. It is still water. Now look over at the right side. Flammability, reactivity with acids. These are your chemical properties. Think about it. You can't test if a piece of paper is flammable without actually setting it on fire, right? And once you do that, well, you don't have paper anymore. You have ash and gas. So one side is really about measuring the state of things exactly as they are, and the other is all about measuring how they react and transform. Let's move to Section 2 and see how this builds in the real world. Let's take these abstract definitions and ground them in everyday reality. Let's walk through this together. First up, we've got ice melting at 0 degrees Celsius. The change here is from a solid to a liquid. But as we just talked about, it's still water. Therefore, pure physical change, no doubt about it. Now look at the second row. Iron. Have you ever accidentally left your bicycle out in the rain? What happens? It rusts, right? The iron actually reacts with the oxygen and moisture in the air to create a completely different substance called iron oxide. Because a brand new substance is born, rusting is a chemical property. And finally, my absolute favorite example, wood. Wood is just fascinating because it lets us see both properties super clearly. When you look at a piece of wood, you see its color, you feel its density, you notice the grain, physical properties, right there. But toss that same piece of wood into a campfire and its flammability takes over. It burns. It creates ash, heat, gases. That ability to burn, that is a chemical property. Literally everything around us is this incredible bundle of both physical and chemical properties. Section 3. Why these properties actually matter. Now, you might be asking yourself, okay, so why do these properties actually matter outside of an 8th grade science classroom? Well, the practical stakes are massive. Knowing these properties isn't just some fun trivia game. It's quite literally the foundation of our modern world. First off, it guides the safe handling of materials. I mean, if you don't know the chemical reactivity of a cleaning supply, you might accidentally mix it with something that creates a toxic gas. Yikes. Furthermore, it ensures purposeful material selection. This is what empowers engineers to design safe skyscrapers. An engineer absolutely has to know the physical hardness of steel, plus its chemical resistance to rust, before they build a 100-story building that you're going to stand in. And it allows chemists to create life-saving medicines. They have to predict exactly how a chemical compound is going to react inside the human body. Everything built, engineered, or synthesized in our entire society relies on a deep, deep understanding of these physical and chemical properties.
Section 4. Checking your understanding. Time for a quick review.
We've covered the what, the how, and the why. Now let's put your knowledge to the test. Question number 1. Why is boiling water a physical change? Think about it for a second. You put a pot of water on the stove. You turn up the heat. It starts bubbling frantically. Steam is rising into the air. A massive change is happening right in front of your eyes. So why, scientifically speaking, do we classify that as merely physical? Yes, because it is absolutely, fundamentally still water. You nailed it. It just changed its state from a liquid to a gas, what we call water vapor. But if you were to capture that steam and cool it down, it would condense right back into liquid water. The chemical identity, H2O, never changed for a single second. And that is the absolute hallmark of a physical change. Okay, let's push a little further with question number 2. We talked about the campfire a minute ago. Why is flammability a chemical property? When you strike a match or ignite a lighter, why is that fundamentally different from just melting an ice cube? And this brilliantly illustrates our core concept, because burning creates completely new substances. You start with wood and oxygen, and you end up with ash, carbon dioxide, and water vapor. You cannot just easily take that pile of ash and magically turn it back into a log of wood. A total transformation has occurred. The identity of the original matter has been completely rewritten. Excellent job! Section 5. Education, Morality, and Peace. As we draw this explainer to a close, the source material actually makes a really interesting pivot. It moves from the physical safety of chemistry to a core philosophy regarding spiritual and mental safety. The heroesmartacademy philosophy states that education must be intertwined with biblical morality. The curriculum essentially argues that just like a chemist needs strict rules to keep a lab safe, individuals need a moral compass. According to this framework, being incredibly smart, highly educated, and knowing all the physical and chemical properties of the universe, well, it's incomplete if a person lacks the moral guidance to use that knowledge responsibly in the real world. And this concept is anchored by Romans 8:6-7, which promises peace of mind to everyone who keeps their mind spiritual. The source material uses this to tie the entire lesson together. It presents the idea that combining scientific literacy of the physical universe with a spiritually grounded morality brings ultimate balance. In this philosophy, having that balance, being scientifically literate while also being morally grounded, is the true experience of a complete education. So that leaves us with one final, pretty thought-provoking question based on today's curriculum. Just like matter has properties that reveal its true identity under pressure or heat, the source asked you to consider this. What kind of properties will you display when tested by the world? When the heat is on, what will your fruit show? I really hope this explainer has opened your eyes to how this material connects the basic physical laws of chemistry with foundational human traits. Keep exploring, keep learning. Thank you so much for joining me today.